Revolve the object with respect to observer. Revolve the object and according to its revolution, draw its three views. The second method, the observer move around the object. He moves around the object, take view from one side, view from another side, and so on. The third method, that is glass box concept. We assume that the object is lying inside a glass box. We draw its projections, and that is the glass box object. Now let me see all these three methods one by one. The first one, revolve the object. Suppose the object is of the shape like this as shown over here, L shape object. If you want to draw its front view, it could be drawn like this. This is an object, so revolve this object towards us like this. This object is revolved towards us, and this would be its front view, right? So if you look from the front side, this object would appear like this. Now revolve the same object to draw its side view like this. This is an object, the same object. Revolve it like this. So this shows its side view, as it's a right hand side view, or you can write it as a right side view, as reverse L shape. Similarly, to draw its top view, let me put the object over here and revolve this object like this. So this represents its top view. This AG would be visible. This is the bigger rectangle. So these are the three views by the first method, that is revolving the object towards us. Now second method, observer move around. In this method, the object remains stationary. It retains over here, and the observer will move according to its required views. Suppose first the observer is here, and it looks this, and he looks the object from here. So put a cutting plane or a projection plane over here and take projections from here to here. So this is the front view. If you look from here, this would be its front view. Now observer has drawn its front view. Now to draw its side view, observer has to move from here to here. To draw its side view, do the same procedure. Put a projection plane over here, take projections from here. This is an object. We take projection from this. So this would be the projections, and L shape would appear as the right side view of this object. Similarly, observer has to move to top side to draw its top view, right? So observer is here, could be seen. Now observer is here, so he has to draw its top view, and this would be its top view as shown by blue colored rectangles, which could be projected in this cutting plane or in this projection plane over here. So in this case, observer has moved from here to here to here, and the object remained stationary. Now third concept, that is glass box concept. In this concept, we assume that the object is lying inside the glass box as shown over here, and we project its views in three direction. Project its front view, top view, and right hand side view, and after that open this glass box from here. Suppose the glass box is hinged from here, and we can open that surface, so it would appear like this. The glass box is opened from here and from here also. Here also it is hinged portion. We open this portion. Similarly, bottom view, all these four sides are open, and the back side is also opened. So total 6 sides are there. You can see here, this is a rectangle or cube. It is having 6 sides, and all these 6 sides are open one by one. One is here, another is here, and rest all are here. Bottom view, then this is the bottom view, Here left hand side view would be there, and here rear view would be there. So here all 6 views are opened, assuming that the object is lying in the glass box, and you can see here the similarities between the views. This is front view and this is rear view. Both are symmetrical, are of the same shape and dimension. Only one difference is there, that is the line type. Here this line is visible fully, and here the same line is dotted line. Similarly, left hand side view and right hand side view, both are of the same nature, same shape, and it's a mirror image of each other. And same is true for this top view and bottom view. Bottom view and top view are also mirror image of each other, only this line type differs, as this is a dotted line and this is a full line. These are the 3 views, 6 views of this object: front view, right hand side view, left hand side view, top view, bottom view, and rear view. You can see here various parameters, that is height. Height of this object will remain same in front view, in 2 side views, and in rear view, right? Similarly, its width will remain same in front view, in bottom view, and in top view. It is same in these 3 views. Similarly, its depth is same in front, in top view, its width in side view, in both the side view, left hand side view and right hand side view. So these are the parameters to represent the object 6 views. Now what is isometric view? This is an object and this is the isometric view of an object, and how to draw its multi-views. So employ a glass box theory. We assume that the object is inside a glass box as shown over here. If we look from the front side, if we look from here, then this object would appear as shown over here. This edge, straight edges would be there, which is represented by 2 straight lines. This edge is shown by this full line, and this curvature shape or arc is represented by this arc. So this is the front view of this object. Similarly, its rear view or back view would appear as shown over here. Only one difference is there with respect to front view. This line and this edge would not be visible, hence represented by dotted line over here and dotted line over here. So that is rear view and this is front view. Now think about its top view. If we look from the top side, this edge, this cut portion would appear, so which is shown over here. This would be its top view. This curvature shape would not appear, and that would appear as a rectangle, which is represented over here. So this is top view, and this is the bottom view. Bottom view also similar to top view, only this line, internal line, which is drawn over here, that would appear as a dotted line from here to here and here to here. So that is bottom view. Similarly, 2 side views, right hand side view and left hand side view. If you look from the right side, the object would appear as shown over here. These 2 lines are dotted lines. If you look from the left side, these 2 lines would be fully visible. So only the difference between 2 side views are the types of line as shown over here. So for this object, as we have employed first angle projection method, the symbol is drawn over here, symbol of first angle projection method. Its front view, this is the front view of this object. Top view of this object would be seen like this, and bottom view, this is the bottom view of this object. Right hand side view is this one, and left hand side view would be this one. In all these views, rear view can be drawn or back view to the right side of the left hand side view over here. So you can compare the views, front view and back view or rear view. Only this line is differing. This is dotted line, this is dotted line, here it is full line. In case of bottom view and top view, only one difference is there. These 2 lines are dotted line over here, and here full lines are there. Similarly, in two side views, left hand side view and right hand side view, here this is dotted line and dotted line, here that is the full line. So I hope these 6 views are clear to you. Now glass box theory employed to another object. The object is placed in the glass box as shown over here. The sides of the box represents the 6 principal planes. 6 planes are there. 4 planes, 1, 2, 3, 4, 1 upper and 1 lower. All these 6 planes are its 6 views. The image of the object is projected on the sides of the box as shown over here. All these images of this object is projected on all these 6 sides of the box as shown over here. Things to notice in this diagram: the projection planes, 6 projection planes are there. You can see here this is a projection planes, or say side of the box, that is projection plane. The projectors, projector means these lines drawn from the edges to this upper plane of this box, or this is the top plane of the box. So line drawn from this corner to here, this corner to here, that is called as projectors. And how surfaces A and B are projected, that you can see here. This surface A, which is projected to its top view like this, and surface B, which is an inclined surface, but this inclination will not be visible in top view. Hence this inclined surface will appear as a rectangle in top view, which is represented over here, and this inclined portion will appear in front view, this by this slant line, this is inclined line. This inclined line represents this cut portion, and in top view this curvature shape would be visible, which is shown over here. So this is true shape of surface A, which is represented over here, and for this surface B, it's a foreshortened shape of surface B, because surface B is inclined and it's having longer length, but it is shrinked over here. It's a foreshortened. So this is not the true shape of B, but for A it's a true shape. The box is unfolded, creating the 6 principal views. If you unfold all these 6 planes, it would appear as shown over here. So 6 views are visible over here: front view, 2 side view, top view, bottom view and rear view. Now principal views. How many principal views are there? So there are 6 views. Name each view. This view is called as top view. This is front view. This view is called as right hand side view, which is drawn to the right side of the front view. This is here, in this case, third angle projection method is employed. This view is called as the rear view or back end view. Similarly, this view is called as left hand side view or left side view, and this view, which is drawn below the front view, it is called as the bottom view. So this is the first third angle projection method. Front view is drawn below top view. What are the differences between the right hand side view and left hand side view? You can notice here only one difference is there. They are mirror images with one different line type. Both are mirror images of each other, only this line type differs in between these two. This is a full line and here it is a dotted line. Now what is difference between top view and bottom view and front view and rear view? You can notice here, in top view and bottom view, line type is differing. They are mirror images with different line type, and in front view and rear view also one difference is there. These lines are dotted line, and here these lines are full line. Which views have the least amount of hidden or dashed lines? You can, from all these 6 views, you select the views which are having the least amount of hidden line or dotted line or dashed line. You can see here, in comparison with front view and rear view, front view is having less dotted lines, top view is having less dotted lines, and right hand side view is having lower number of dotted lines. Hence, to represent the orthographic projection of this object, we should select front view, top view and right hand side view, and not left hand side view, bottom view and rear view. These three views should be erased because they are having more number of dotted lines, and with the help of these three views, front view, top view and right hand side view, we can express all the requirements of these drawings of the object. So front and top views should be selected to draw this object. Now one exercise, do this exercise at your own. Fill the following dotted orthographic projection with the appropriate line types. Suppose this is an object and we have to draw appropriate line type. Which line would appear as a full line or dotted line? That we have to draw in this portion. You have to do this exercise at your own in your homework. Let me do a quick review of this exercise. So this is an object. If you look from the top, this yellow colored portion would appear to us. So that is to be represented by full line. This circle will be full line. This is the full lines. You can see here. This edge is not visible. Hence, this line would be represented by the dotted line. This one. Now what's about side view? So for that, fill in the visible lines in the front view. If you look from the front, this blue colored portion would be visible to us. Hence, this blue colored portion can be drawn with the full line. This line also would be visible. So this line would be full line, like this. So this is the front view of this object. Now regarding right hand side view, so for that, fill in the visible lines in the right hand side view as drawn over here. If you look from here, this slant edge would be visible. So this edge to be drawn with the full line, and this would be the right hand side view. I hope it's clear to you. And rest of lines would be dotted line, which is drawn over here. Fill in the hidden lines into front, top and right side views. This line would be hidden line or dotted line in front view. These two lines shows this circular hole which is drilled inside this upper surface and lower surface, shown by dotted lines over here. If you look from the right hand side view, this edge, these two edges will not be visible, which starts from here, ends to here.